So this question says a rod of mass m length L is lying on a smooth table. A ball of mass m hits the rod with a horizontal velocity u. If the coefficient of restitution is e, find the angular velocity after the impact and velocity of end A when the rod has rotated by angle 90 degree. So the situation looks something like that. It is a rod and there is a ball that is coming towards the rod and it hits the rod with a velocity of u, and the collision is elastic. So collision is okay, coefficient of restitution is given. So after collision, if I draw the situation, it will look something like that. After collision, the velocity of the ball will be changed because the ball also experienced an impulse. Suppose the velocity of ball is v and velocity of the center of mass of the rod is vc, as well as the rod starts rotating about its own axis with angular velocity omega. Can I draw these two conditions for before and after? Yes or no? Can you identify the before and after situation of the collision? Now in this collision, if I want to conserve angular momentum, about which point I can conserve the angular momentum of the system? Now my system includes this entire body of the rod and the ball, right? So this is entire my system. So if it is my system, what I can say about the angular momentum conservation?
It can be conserved about any point.
It can be conserved about any point. Yes, because there is no external force or the impulsive force is there on it. So can I take any point that lies on this line of impact? Any point. Suppose I assume a point P here, right? This point P here. That point lies on the line of the impact. And this point is not inside any body, rather, it lies on a space, a fixed point. Can I conserve angular momentum about this point P? Yes or no? Angular momentum about P is also conserved.
Yes, sir.
Can you tell me what is the initial angular momentum of the system about point P?
0.
0. Because the particle was moving along this point P. So the velocity momentum vector passes through point P. The rod was at rest. After collision, what will be the angular momentum of the same system about the same point P? As the point is external to the body, we'll use the formula angular momentum is equal to IC omega plus mr cross Vc, right? So if you use this formula, what you will write as angular momentum of the body first? What is angular momentum of the ball? Is it still 0? Angular momentum of the ball about this point P?
Yes, sir.
What is angular momentum of the rod about point P? What can I say about that? Angular momentum of the rod about point P. Can you find what is that?
Sir, m into 2 into L by 6.
M into L by 6. M into L
Into
by
V
6 into Vc.
minus IC omega
Ic is what?
ml square by 12.
Ml square by 12 omega. Yes. Good. Look, M r cross Vc is going into the plane. This is L by 3, so this distance must be L by 6. Right? This distance must be L by 6. So M r cross Vc going into the plane and Ic omega is coming out of the plane. So if I now conserve it, look, I can directly find a relation between Vc and omega from this one expression. So ml by 6, if I cancel, then Vc is equal to omega by into L by 2. Yes or no? Vc is equal to L omega by 2. That is the first expression that I can write.
স্যার
হ্যাঁ বলো।
স্যার অ্যাঙ্গুলার মোমেন্টামটা বার করার জন্য আমরা সেকেন্ড ফর্মুলাটা কেন ইউজ করলাম?
Because this point is not inside the body. We use the second formula whenever the point of concern is outside the body. If it lies inside the body, about which the body is in pure rotational motion, then only we can use IC into omega, I into omega formula. I about that axis into omega. But I cannot find I about that axis because it is not a rigid body about this point. Right? This point does not lie inside the body. So definitely we have to use the second formula. What else we can conserve in this same question?
স্যার মোমেন্টাম লিনিয়ার মোমেন্টাম।
Linear momentum we can also conserve. And what is that linear momentum conservation equation?
So small mu equals to capital M Vc plus small m V.
Small mu is equal to capital M into Vc center of mass plus small m into V. Right? Two equations we have got. How many unknowns are there? Can we solve these two equations? Vc omega and V. Right? Three and another equation can I write as coefficient of restitution?
Yes, sir.
Yes, and what is that equation? Can you tell me? What would be coefficient of restitution equation?
Vc plus omega L by 6 minus V by U.
One second. Yes. Coefficient of restitution only depends on the point of contact and their velocities. So what is the velocity of the point of contact of the rod? Is it Vc plus L by 6 omega? Yes or no? Point of contact of the rod just after collision. Is it Vc plus L by 6 omega? And the velocity of the ball after collision is V divided by velocity of the ball before collision is U and the rod is 0. Can I write this is the coefficient of restitution? Yes or no?
Yes, sir.
So with these three equations, now I can solve the question L omega by 6. So from here I can say E into U is equal to Vc plus L omega by 6 minus V. Now L omega by 6 is equal to Vc by 3. Right? So Vc plus Vc by 3. EU plus V is equal to 4 Vc by 3. Right? And also I can find from here that U minus V is equal to capital M by small m into Vc. From these two equations, I can find what is the value of Vc as well as V. If I add these two, then U into 1 plus E, U into 1 plus E divided by M plus 4 by 3. Is it Vc? If I add these two, 4 by 3 plus M is equal to EU plus U. So Vc I have got like this. Yes or no? If I know what is Vc, I can find what is omega. Omega is equal to 2 by L Vc 1 plus E divided by M plus 4 by 3. And velocity of end A. Now the second question says, what is velocity of end A when the rod has rotated by 90 degree? So suppose the rod was initially like this, just after the collision the situation is this, and when it has rotated by 90 degree the situation is this, right? So in the second question I can say that when the rod has rotated by 90 degree with respect to center of mass, okay, will this omega change as it is kept on a smooth table? Will that omega change or it will remain the same?
It remains the same.
If it remains the same, then with respect to center of mass, the velocity of A is equal to L by 2 omega only, right? And the velocity of center of mass, will it change? Velocity of center of mass? As there is no external force on the rod now there is no collision is over. So will that velocity of center of mass change?
No, sir.
So what is velocity of A? Velocity of A with respect to ground, is it not the vector addition of Vc and L omega by 2? And you can see L omega by 2 is nothing but Vc. So this answer is root 2 Vc. Velocity of A after it has rotated by 90 degrees, root 2 Vc. Have we got it?
Yes, sir.
Okay. So we have done
Sir?
this question. Yes, tell me.
Sir, we could have also solved this question from by conserving the angular momentum about initial position of comb of the rod.
Initial position of the center of mass of the rod, but that point should
Yes,
be on the space. That point should not be lying inside the rod. If you
yes, sir.
take it inside the rod, then it will be not possible because that entire system, if you think on this rod, there is an impulsive force, right?
Yes,
So you cannot do it by taking only the center of mass of the rod. Uh, but if you take a point on the space just below that center of mass, suppose this point, you can do it.
yes, sir, like that.
Yes, you can do it. All right. Have we done this question?
No, sir. This was homework.
A rod of mass m length L falls from a height h and its end hits the corner of a table. If the impact is elastic, find the angular velocity of the rod just after the impact.
Sir, is it 4 root over 2 GH by L?
4 root over 2gh by L. Okay, let us check. Situation is something like that. Initially, the rod just before collision was having a translational motion only. Yes or no? So
Yes, sir.
each of the point of the rod was coming with a velocity root 2gh. Now, just after the collision, the velocity of this point as the collision is elastic will be upward root 2gh. Yes or no?
Yes, sir.
This point I am talking about as it collides with that corner. So coefficient of restitution, if you apply it to be
Sir,
1. Yes.
sir, will that point be means? Oh, okay, sir. You are taking the end point's velocity is root over 2gh.
Yes. All the points are coming with root 2gh only. It is a
Okay.
translational motion initially.
Yes.
Right? So if I say that its endpoint will now move upward with root 2 gh velocity, and let us assume that center of mass is coming down with velocity vc, and there is a omega here. So about which point I can conserve the angular momentum? Can I say this point of contact where the impulsive force lies, I can conserve angular momentum because the torque of impulsive force will become zero now? Yes or
Yes, sir.
no? So angular momentum about P is conserved. Angular momentum about P is conserved. Can you tell me
Sir,
what
would you
was?
please repeat the last part? I got disconnected.
I've said that when the rod hits this corner of the table, then whatever is the impulse, that impulse passes through the point P itself. Yes or no?
Yes, sir.
So if it passes through the point P, then the torque of impulsive force about point P becomes zero. So I can conserve the angular momentum about point P. Right? So what is angular momentum of the system about point P before hitting the table?
M into root over 2gh into L by 2.
Yes. Yes. Angular momentum before it is just it has no omega. So IC omega part will be zero. But as the center of mass is coming down, can I write it is simply m into root over of 2gh into L by 2? Yes or no?
Sir, I am having one doubt.
Yes, tell me.
Sir, why won't the velocity of center of mass of the rod be root over 2gh in the upward direction?
It's not velocity of center of mass. Why I have not written root 2gh upward direction. I have only written the velocity of this point will be upward root 2gh direction. Root 2gh in upward
Sir,
direction, not the velocity of center of mass, because when you write the coefficient of restitution, you think about the center of mass or you think about the point of contact. Have I mentioned it in last class that the coefficient of restitution is written by taking which points? Points of contact or the velocity of center of mass?
Point of contact.
Point of contact only. So the point of contact is moving upward, not the center of mass is moving upward. Is this okay?
sir, would you please repeat that? I got disconnected again.
I said that you write the coefficient of restitution by taking which points? Points of contacts or the of the center of mass?
The point of contact.
then the point of contact will reverse its direction, not the center of mass. I cannot say anything about center of mass unless I find the equations.
Sir, but don't we write the velocity of center of mass while conserving momentum?
Yes, definitely. By conserving momentum, linear momentum, always take the center of mass velocity, but the coefficient of restitution, it solely depends on the velocity of the points of contacts.
Yes, sir, understood.
All right. Now, the linear momentum before collision is m root 2gh into L by 2, and that should be the angular momentum just after the collision. Can you tell me what is the after collision angular momentum about point P if I mention it? What will be after collision angular momentum?
MVC into L by 2 minus ML square by 3 omega.
MVC L by
Sorry,
2.
ML square by 12 omega.
Yes. MVC L by 2 is coming up the plane, and IC omega, is it coming out or down, going into the plane? MR cross VC. What is the direction of MR cross VC about point P?
Plus only.
Yes, both will be plus, because this MR cross VC is also coming towards us, and IC omega is also coming towards us. So I will add this plus IC is ml square by 12 omega. Have I written correct expressions? Look. They're correct? Okay. I think we can have a relation between V and omega from this equation, but still I have to find what is the relation between V and omega. Right? Any other equation that I can write?
Say velocity of point P with respect to center of mass is L by 2 omega.
Velocity of point P with respect to center of mass is L by 2 omega. Good. So from constant equation, I can write that velocity of point P with respect to center of mass is, with respect to center of mass, velocity of point P is root 2gh plus Vc. Can I say that is equal to L by 2 omega? Yes or no?
Yes, sir.
So these two equations will definitely solve your question. So let me first write down the first equation. Root 2gh is equal to Vc plus L omega by 6, right? And L omega by 2 is equal to Vc plus root 2gh. So L omega by 6 is equal to Vc by 3 plus root 2gh by 3. So I think 1 minus 1 by 3 is 2 by 3 root 2gh. 2 by 3 root 2gh is equal to 4 by 3 Vc. So is Vc equal to half root 2gh? And the angular velocity omega is equal to Vc plus root 2gh is equal to 3 by 2 root 2gh, right? So I think it is 3 by L root 2gh, isn't it? Check if my calculations are okay. This question, have you done? Have I given it?
Yes.
As your
Yes,
homework?
it was.
Yes. All right. So the similar type of thing, but instead of particle, now the rods are colliding. Right. The question says two identical rods are moving on a smooth table as shown. Both of them are rotating with omega. Both of them are rotating with omega. Okay. uh, in clockwise about their center. Their centers have velocities v in opposite direction. The rods collide at their edge and stick together. Length of each rod is L. For what value of v by omega L will there be no motion? If the ratio is half of that found, what fraction of kinetic energy is lost? Okay. Look, this type of questions may come, but you can solve it, right? You can solve by whatever concepts we have learned so far. No new concepts we will use. So suppose this is the rod and this is one another rod. Again, the question is if I take them as a system, about which point I can conserve the angular momentum. What should be the answer of this question?
About any point.
About any point, right? But I will preferably choose this point,
Yes, sir.
right? Midpoint, symmetric point. So if I say what is the initial angular momentum about this point P, I'll conserve angular momentum about P. So tell me what is the initial angular momentum about point P? This rod was coming with velocity v. So for this it is m L by 2v, right? Upward direction coming towards us. And omega is like this. Omega is going into the plane. Yes or no? So minus ml square by 12 omega. For this rod it is going up and omega is in this direction. So it is RC MR cross VC. If you do MR cross VC is also ml by 2v. Yes, it is coming to be the same, and minus ml square by 12 omega. Now final
Sir, instead of 12.
instead of 12, yes, good. So now finally the situation is that entire rod becomes a single one, right? They are attached each other, and then I can say that the velocity of this rod, suppose the center of mass of this rod, the entire system, suppose it has become Vc, and this entire rod is now started rotating with an angular velocity omega prime. P point lies just below the point C. So if I now find what is the final angular momentum of the system, what should I write? What is the final angular momentum of the system?
Sir, m into 2l square by 12 omega dash.
ml square by 12. Now L is 12.
Yes, sir.
Right? And there is no MR cross VC because this point is just below the point C.
Sir, it will be 2m.
Yes, the mass is 2m. So if I now equate these two, I will find the value of omega prime. Right? So L initial is equal to L final. That will be mlv minus ml square by 6 omega, right? And that is equal to, one second, yes, and that is equal to 4 by 6 means 2 by 3 ml square omega prime. Can I write it? And if I conserve the angular momentum, can I directly find that the value of Vc is 0? Conservation of
Yes.
linear momentum. Conservation of linear momentum gives Vc equal to 0 because initially the momentum was minus mv plus mv. So Vc is 0. So if there is no motion, what do I mean by that? Omega prime should also be 0. For no motion, omega prime should be 0, and that gives V by L omega is equal to 1 by 6 or not? Have we got the answer to the first question? Yes or no? Now the second question says, if it is half of that, means if V by L omega is equal to 1 by 12, then from this equation only I can say 2 by 3 L omega prime is equal to V minus L omega by 6. So V is equal to L omega by 12 minus L omega by 6. Is it minus L omega by 12? So omega prime will be equal to minus omega by 8. Yes or no? It will start rotating in opposite direction. So what is the kinetic energy? What is the change in kinetic energy rather? That we can calculate, I think. Right? The change in kinetic energy will be initially is half m 2 into half mv square plus half ml square by 12 half ic omega square, and finally it is only half ic is 2m by 12 into 4l square into omega prime square, omega by 8 whole square. Right? Whatever is the answer, you can find it. If v, you can put L omega by 12. So in terms of L omega or in terms of v, you can find your answer. So that should be the answer of this question. Have we done it? I have given this as your homework.
Yes, sir.
Yes. A ring of mass 2m rests on a smooth table when a small particle of mass m hits the lowest point and sticks with it. What is the angular velocity of the combined system and velocity of the center of the ring after this impact? A very similar type of question. Have you done it? Anyone found the answer of this question?
Yes, sir.
Yes, what you have got?
Sir, velocity of center of ring is u by 3, and angular velocity is 2u by 9. I used the radius, but it's not given.
Yes, radius is needed. Okay, let us check. I don't remember if the answer is this one.
Sir, velocity of the center of the ring cannot be u by 3 as that will be the center of mass of the system.
Yes, I also think so. The velocity of center of ring is not u by 3. Okay.
Okay, so then we don't
Identify where you have done mistake. Okay. So it is very important to write the before and after conditions, right? To draw the before and after conditions. So it is the before condition when a particle with mass m hits this lowest point and after it gets embedded in it. So initially the ring did not have any omega or velocity. Finally, can I say that the ring has a velocity vc as well as it starts rotating with angular velocity omega? Can I assume it? With my assumption, what is the velocity of this particle after collision then? Can you tell me what is the velocity of this particle then?
VC plus omega r.
Vc
So
plus r
VC
omega.
minus.
Vc plus.
Yes, sir. VC plus.
Vc plus r omega. About which point I can conserve my angular momentum? Here about which point? Yes, any point. Any point, but I will take this point along the line of motion of the particle. About point P, I can conserve angular momentum. So what is initial angular momentum about point P? Is it 0 or not? And what is final angular momentum about point P? Can you tell me what is the final angular momentum about point P? Initially
Minus IC omega.
0, finally yes.
Same VCR minus IC omega.
2m into Vc into R minus IC omega. What is IC? 2m into R square.
Yes, sir.
2m into r square by 2.
It should be R square, na? The ring.
Yes, sir. R
Yes.
square.
Yes. So 2m into R you can cancel. So the relation is Vc equal to R omega. That is one equation you have got. Any other thing you can conserve? Apart from this angular momentum, what we can else conserve?
Linear momentum.
So conservation of linear momentum will give me m into u is equal to 2m Vc plus m into Vc plus R omega. Yes or no? So that is 2m Vc plus 2m Vc, 4m Vc. So is Vc is equal to u by 4? Yes or no? If the velocity of the center of the ring is u by 4, and what is angular velocity? U by 4r. I think these are the answer of this question. Check, this is not a tough question. Have you got it?
Sir, why is it minus IC omega?
It's mr cross Vc plus Ic omega, but the directions of mr cross Vc and Ic omega are opposite. Look, if you say this is the r vector, rc vector and Vc vector, what is the direction of rc cross Vc? rc cross
Upwards.
Vc going into the plane or not?
Yes, sir. Yes, sir.
And Ic omega is coming up the plane. That is why a negative sign is there.
Okay, sir.
Sir,
Yes.
sir, when we are conserving angular momentum,
Yes.
and in the after the collision, that point IC will not include the mass of the ball.
Ic, no. Because I am conserving, here I am finding the angular momentum separately. First of the ring, then of the ball. Right? If I take them as a system, then My IC will not be here. My IC will be somewhere here. The center of mass of the system is not here. Somewhere here.
Oh yes,
Right.
sir.
In that case, you have also you have to consider this mass. But you can always, if there is a rigid body of two or three different parts, you can take the parts separately and calculate the kinetic energy as well as the angular momentum, and then simply add them. For angular momentum, vector addition; kinetic energy, scalar addition. I think this is okay to everyone. This question is yes, a good question. A uniform square plate ABCD has a mass m and side length a. It is sliding on a horizontal smooth surface with a velocity of v vector as v naught 4 I cap plus 2 j cap. Translational motion it was doing. There is no rotation. Vertex A of the plate is suddenly fixed by a nail. What is the velocity of the center of the plate immediately after this? Have I given it as your homework?
No, sir.
Okay, then you can try this one. So, whatever maybe impulse is there, is it passing through only point A?
Yes, sir.
So, I can conserve the angular momentum, I think, about point A. Yes or no? Initially, if you think that it had no rotation, only the center of mass was moving with some velocity 4 I cap plus 2 j cap. So, what is the angular momentum of this initial angular momentum? I can say initial angular momentum I can measure about A. What it will be?
M into A by 2 into 4 V naught.
M into A by 2 into
4
4
V naught.
V naught. Okay, it is V naught. What about 2? 2 is also there, right?
Sir, but R cross VC.
Yes, R cross VC. So M into A by 2. For this 4 V naught, the distance is A by 2. But for 2 V naught
Okay.
is also A by 2. Yes or no? So 4 V naught is minus K cap, I think. If you cross R cross 4 V naught, it is minus K cap. And if you do a cross product of M into A by 2 into 2 V naught, what it will be? Plus K cap, yes
Sir,
or no? Yes, tell me.
sir, over here, are we calculating the angular momentum about a
Yes,
before that nail
before.
is placed?
Yes, before the nail is placed, the point A is just below the point A actually. It is on the space only. So I am calculating M R cross VC. M R cross VC plus IC omega, but IC omega here it is what? IC omega is 0?
Sir?
Yes.
Sir, if the point A was on the square plate only, then won't that angular momentum be 0?
I am not taking point A on the square plate. If you take point A on the square plate, can you conserve angular momentum? Because that point has had an initial velocity, and within a very short time interval its velocity became 0. So it had experienced a tremendous acceleration. Yes or no? So due to that
Yes,
acceleration,
but
there will be a pseudo force that will not pass through A, but that will pass through the center of mass. So that pseudo force can have a torque about A. Can I conserve angular momentum about point A? Or you can say it is A prime actually. A prime is just below A. Is that okay to you?
no, sir, I could not understand this one.
You could not understand this one. Look, if this is the square plate, suppose this is the square plate, and I have taken a point A prime just below the point A when the collision is happening. You can say that A is undergoing a collision here, yes or no?
Yes, sir.
Yes. Now the difference between A and A prime is if you sit on the point A, right? After a very short time interval, A had a velocity v. Suppose A had a particular velocity in this direction before, and after A become at rest. So don't you think that point A is a non-inertial reference frame? It has an acceleration in this direction. Yes or no?
Yes, sir. Sir, then won't the pseudo force pass through A only?
How you can be so sure that pseudo force will pass through point A? Pseudo force will pass through point C, center of mass, and it will be opposite to acceleration, m into AA. But how can you say that the pseudo force will pass through point A? If you consider in this diagram only, let me draw it in top view. In top view, acceleration of A, is it necessary that it will pass through C? The direction of acceleration of A,
It will not pass through C.
will it be in this direction or not? It can be in this direction, it can be in this direction. So if it is in this direction, the pseudo force will pass through this point. And that pseudo force will be an impulsive because look, the acceleration is very high of very high magnitude. Yes or no? So can we conserve the angular momentum about A which lies on the plate?
So one thing to us is that means the force on that point A, the direction of that force on point is same as the direction of acceleration of point A. We can say this one.
Yes, definitely.
So then, if we assume that the direction of force is not just opposite of the direction of velocity when we consider the point A,
Yes.
so then won't the point A have means something velocity left with it?
No, then how it can be at rest? Point A, when you nail it, it will be completely at rest. If it has a velocity, how it can be at rest? It cannot have a velocity. Its velocity is instantly becoming zero.
Sir, its velocity is zero. So, sir, can't we say that the direction of force is just opposite to the direction of velocity of point A?
Yes, that only I have drawn here. The velocity of point A was not towards center C. Initially, what is the direct resultant velocity of this 4 and 2? If it were 4 and 4, then definitely you could have taken point A. If both are 4, but it is 4 and 2. The velocity of A is also 4 and 2. What is the direction of 4 and 2 resultant? Is it passing through C?
Oh, okay, sir. I now understood.
Have you got it?
Yes, sir.
So A prime is just below A. Now there is no problem on A prime. Can you see that? Because A prime point is a fixed point. It is lying on a space. So it has zero acceleration always. You can take momentum, angular momentum about this point. What is initial angular momentum? Just before that nail is hinged, it is 2 ma v naught minus k cap and plus ma v naught k cap. So is it minus ma v naught k cap? Yes or no? It is before collision. The situation is before collision. After collision, if you look to the situation, after collision, point A prime is here only. Let us assume that after collision, the center of mass starts rotating about this point A with angular velocity omega. This entire body is now rotating only about point A. Yes or no? So after collision, if I write what is angular momentum about A prime, what should I write?
ml square by 6 plus ma square by 2 into omega.
Yes. You can say these points are same. So again, if you assume this point to be outside point, so it is better to use the second equation. But I think both of them will be same. The second equation says that it is m r cross vc. That means m into a by 2 into vc is a by 2 omega m r cross vc plus m ic omega. What is moment of inertia about this axis? Ic. Is it this one? I think m a square by 12 and this is ml square by 12. So it is ms square by 6, I think, right? Have I got it? Velocity of center of mass is a by, sorry, it's not a by 2. It should be a by root 2. Right? It is a by root 2 omega. This distance is also a by root 2. So RC omega is coming up the plane. Both of them are k cap. RC omega is coming up the plane and IC omega is also coming up the plane. If you add it, I think it is ms square by 6 plus ms square by 2. 3 ms square by 6, 4 ms square by 6. So I think it is 2 by 3 ms square omega. Even if you find the moment of inertia about A prime, this point, I think it will be the same. About it is ml square by 3, about it is ms square by 3. So it is 2 ms square by 3. Can I find omega from this two calculation? I think omega will be opposite. We have taken a wrong direction of omega because initially it was along minus k cap. Right. So as final and initial are same, this is final. Is equal to L initial. So I can say 2 by 3 ma square omega is equal to minus ma v naught. M and a you cancel. So omega you will get as minus 3 v naught by 2a. Yes or no? So the velocity of center of mass is a omega by root 2. So I think it is minus 3 v naught by 2 root 2. Can I write it? A by root 2 omega, which is a by root 2 means 3 v naught by 2 root 2. I think that should be the answer of this question.
Yes, sir.
3 v naught by 2 root 2. Check if you have any doubt left, you can ask me. A good question, and you should understand why I have taken a point outside the body, not inside the body. Inside the body is always risky, so always take outside point. Anything else you want to share in this question?
Sir,
Hi, Bolo.
sir, we cannot think it this way that as we are fixing a, the component of the velocity of the center parallel to AO will be 0.
As we are fixing A, then component of
the velocity of the center parallel to AO will be 0.
velocity of center parallel to AO. A or AC is 0. Yes, definitely.
Yes.
Yes.
Sir, but then I'm getting a different answer.
Why? Because from here also you can see that velocity is perpendicular, so parallel component is 0.
Okay, sir. The perpendicular component will also change.
Yes, the perpendicular component will change.
Yes, yes. Okay. Thank you, sir.
You do not know in which direction the net force is acting on point A, right? Actually, that is why you can always take any component in direct components in any direction.
Sir,
Bolo?
sir, why don't we know the exact direction of the force acting on point A? Because that A will come to rest, so it will act in the direction opposite to
No,
initial
but
velocity.
actually, what is the force on A? Is it the only external force? On point A, internal forces are also there. You can only talk about external force if you think about the center of mass.
Yes, sir.
Right? So now you can find what is the direction of force because the velocity of center of mass now in this direction. Initially it was in this direction. Now you can find what is the change in velocity in that direction. You can tell your external force lies.
Sir,
Bolo?
sir, can we conserve linear momentum in the direction perpendicular to the non-impulsive force?
Non-impulsive or impulsive?
So sorry, impulsive.
Yes, definitely you can do it. But here you do not know what is the direction of impulsive force. That is why you cannot do it. Is it okay, everyone? Ask me if there is any doubt. Okay, we'll move forward. A ball of mass m radius r is rotating with angular velocity u by 2r and hits the floor with vertical velocity of the center of mass u. Just after the impact, the vertical component of the center of mass becomes u by 2 upward. Find the angular velocity of the ball just after the impact and the horizontal component of the velocity of the center of mass. Assume the coefficient of friction between the ball and floor is mu and the ball slips during the collision. Try to write down the equations. I'm sure you can find it.
Sir?
Bolo?
Sir, it is given that the ball slips during the collision.
Yes.
That means when it is moving up, that time just before it is moving up, it has achieved that pure rolling condition.
No, it has not achieved. During entire motion, it was only slipping. The collision time is very less, and during that time, it was only slipping. Whenever it was in contact, it was slipping. Have you got the answer of this question? First one?
So please wait.
So is the first one omega minus 15u by 4r?
Omega minus omega value তো দেওয়া আছে u by 2 আর initial omega.
Is u by 2r minus 15u by 4r.
Yeah, that only.
That only you have got.
So u by 12 minus 15 mu by r I'm getting.
All right.
So in the horizontal component of velocity, it's the mu m by 2.
Mu.
No, so that.
Look, the initial velocity is v, u in this direction. Final velocity upward is u by 2. Suppose final horizontal component is v. V in u by 2, it is u, it is omega. So can you tell me in which direction the friction force lies during this collision? Forward or backward?
Forward.
Friction acts in forward direction. And there is also a normal reaction like this. Are both the forces impulsive or not?
Yes, sir.
Because it is kinetic friction, value is mu into n, and n is impulsive, so mu into n is also impulsive. So if I write down the momentum and this impulse momentum equation, if you remember impulse momentum equation, can I write that integral of n dt? Integral of n dt is equal to m into u by 2 minus m into minus u. Can I write it? Just check. The impulse of this vertical force normal reaction, it changes the vertical component of the center of mass, velocity. Vertically it becomes u by 2, initially was u. So is it 3mu by 2? Yes or no?
Yes, sir.
Yes, sir.
And let us assume that finally it has achieved a angular velocity omega prime. So what is the why the angular momentum is changing from omega to omega prime?
The frictional impulse.
Because the impulse of that frictional force and its torque. So can I say integral of fk into r? It is tau into dt. Integral of tau dt about center of mass I am talking about, right? Integral of tau dt. It is equal to final IC omega, which is 2 by 5 mr square omega prime, minus initial IC omega is 2 by 5 mr square into minus omega.
Yes, sir.
So it is 2 by 5 mr square into omega plus omega prime. Now what is fk? It is mu r into integral of n dt, yes or no? Look, mu into r into n dt. Now what is integral of n dt? From equation 1, can I directly put it is 3 by 2 mu?
Yes, sir.
2 by 5 mr square into omega plus omega prime. R gets cancelled, m gets cancelled out. Right? So 15 into mu u divided by 4r minus omega is equal to omega prime. That gives your omega prime is equal to 15 by 4r into mu into u minus omega is u by 2r. So it is u by 4r into 15 mu minus 2.
Sir,
Yes or no? हाँ बोलो.
could we have not conserved the angular momentum about the point of impact?
I think you can do it if you neglect this small displacement. Just after the collision, we can do it. Let us first find it in the first way. Now, the second question says horizontal component of the velocity. What is the linear momentum change in horizontal direction? Can I say change in linear momentum is nothing but the f into dt, which is mu integral of n dt? Yes or no? So mb is equal to mu into 3 by 2 mu. So vertical horizontal component of its velocity will be 3 by 2 into mu u. So these are the answers of this question. These two answer you can find. Have you got it? Check if you have got the solution. Okay. Let us try to solve it. You can also, I think you can take the angular momentum about this point of contact. Just this point, what was the angular momentum initially? Conserved, if I say, initial angular momentum was IC omega only, 2 by 5 mr square omega, yes or no?
Yes, sir.
Downward direction, yes. IC omega is in the minus k cap, and finally it is mr into v plus 2 by 5 mr square omega prime, yes or no? Can I say that? Or minus? It should be
Minus, right?
minus, yes, it should be minus. So 2 by 5 mr square into omega plus omega prime, that is equal to mrv, right? One second. So this is one equation I can find. Omega, omega prime and v. Omega is known, I think, right? Omega prime and v, they are unknown. Omega prime and v, they are unknown. And what else we can write? I think in terms of this vertical component, I can only find by integral of n dt only. Integral of n dt is equal to 3mu by 2. Integral of n dt is 3mu by 2, and integral of f dt integral of f dt is equal to mv. So v I can find in this way only. So mv is equal to mu into 3m u by 2. V is equal to 3 mu into u by 2. If I put the value of v here, am I getting the same value of omega prime that we have got? Just let us check.
Yes, sir.
2 by 5 r. So omega plus omega prime is equal to 5 by 2r into v. 3 mu. Yes, I think we have got the same answer. 15 by 4r into mu into u. So omega prime is equal to 15 by 4r into mu into u plus omega. Omega prime minus omega is u by 2r. Yes, we have got getting the same answer. You can use it. Alright? Okay. Now this question says that angular momentum of a rigid a ball of mass m and radius r is rolling without slipping on a floor with velocity of its center to be u. It encounters a step of height r by 4. The radius of this ball is r. At some high point, it is encountering this. This is something which is preventing its motion. The edge of the step is the friction at the edge is sufficient to prevent any slipping. What is the value of u such that it can just rise above the step?
Sir, is u is equal to 4 by 23 into root over 10 gi by 7?
How we can solve this question?
So we can first take the point on the step where it hits, and then we can consider a pure rotation about that point
Yes, yes.
after collision,
Yes,
and then we can equate the energies.
yes. So we want to know what is the angular velocity just after the collision, just after the impact. That we first want to know. We can definitely conserve angular momentum about this point where it gets hit. Right, this point. About point P. So just after the collision, if its angular velocity is omega prime, just after the collision, its angular velocity is omega prime, I can neglect as it is in pure rolling about point P. I can say about point P it is only moving with omega after. Can I say that? It is ICR point just after the collision. Can I
Yes,
take
sir.
it to be ICR? Yes. And before it was coming with u and omega. Angular momentum about P is conserved. Angular momentum about P is conserved. What is initial angular momentum about point P?
So 3 mu by 4 into r plus IC omega.
Yes.
Yes, this distance is how
It is
much?
coming 23 by 20 MUR.
R by 4, so it is
Yes, sir, 23 20 mu r.
Okay, so going into the plane is mu into 3r by 4, yes or no?
Yes, sir.
Yes, sir.
Plus IC omega 2 by 5 mr square into
U by R.
omega is
U by R.
U by R. Initially it was rolling about this point. This was instant center initially. So it is U by R definitely. It was pure rolling. And finally, can I say that it is pure rolling about point P?
Yes, sir.
So its angular momentum will be 7 by 5 mr square omega.
To omega dash.
Omega dash.
Yes, sir.
I can find omega dash from there only. So it is 2 by 5 mru plus 3 by 4 mru. Mr gets cancelled out. So 2 by 5 plus 3 by 4 into u is equal to 7 by 5 r omega prime. So omega prime we get
23 U by 28 R.
yes, 23 u divided by 28
20.
r. Now as it starts rotating with omega, finally what will be the situation? Finally, when it will just rise above the step, I can assume its omega to be 0. Yes or no?
Yes, sir.
Initially its omega was here. It was here. So its center of mass has moved up by some distance. So whatever is the potential energy gained by its center of mass, I can say it is the loss of its kinetic energy.
Yes, sir.
Right? So the gain in potential energy is equal to mg into h. How much it is? R by 4.
R by 4.
And that should be equal to the initial kinetic energy only, half. Can I say kinetic energy? When I will write, I will take I about P. Yes or no? ICR into omega prime square.
Yes, sir.
23 by 28 u by r whole square. So that will give you your answer. What is the value of u? So gets cancelled out. R square gets cancelled out. 23 by 28 u whole square, that is equal to uh, 2 5 gr 5 gr divided by 14. 5 gr divided by 14. So u is equal to 28 by 23 under root of 5 gr by 14. Have you got that as your answer?
Yes, sir. This one, Mr. 1.
Yes. So this was all about angular momentum conservation and its equations during collision. We have done so many questions. I'm sure you will find a question of any of the types that we have only studied in our class, right? You will never find a new question, but whenever you will find a question, don't panic, just try to write down all the equations. Think what equations you can write. Three conservation principles now you have in your hand: linear momentum, angular momentum, and energy, right? So I think that's all about this chapter of rotational motion. uh, mm, oh, any questions were left?
Same voice is not coming.
Yes, just 1 minute. I think out of the 4 questions that I have given you, 1 question was left. Yes, this question was left, I think, right?
Yes, sir, this was left.
Yes, sir.
Yes. Have you got the answer of this question?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So it's not a tough question. We can now solve it. Suppose this is the ball, 10 kg solid sphere of radius r. It is rolling without slipping on a horizontal rough surface with a speed of 8 meter per second. The force applied by the right half of the sphere on the left half. So if I say that it is rolling, only consider any one half. Suppose I am considering this half. Then center of mass of this half is here. Do you remember where does the center of mass lie for a solid sphere?
So 3R by 8R. 3R by
3r by 8.
Okay.
Yes. So I will only consider this part, right? Only consider this half. What are the forces on this half? There may be a normal reaction, weight is passing through center, which is mg by 2, right? And suppose this right half is giving it a force in this direction, right? It is also moving with constant speed. So I don't think it has any alpha, but it have a omega, right? It has an omega.
So the centripetal acceleration is provided by the fx.
Yes. Now if I see what is the acceleration of that center, can I say that point O has zero acceleration in vertical direction,
Yes, sir.
Yes,
right?
sir.
So with respect to point O, point C has an acceleration omega square 3r by 8 in this direction,
Yes, sir.
right? 3r by 8 in this direction. Okay. So this is normal reaction, and the center of mass here at this instant, this center, is it having any other acceleration? This point O does not have any vertical acceleration. So about point O, this point C,
So
does it,
O does not has any acceleration.
O does not have
No.
any
So
acceleration.
O does not have any
Yes,
vertical
O
or
does
horizontal.
not have any acceleration. So point C has this horizontal acceleration only, right? So I can say that the net force on it, the horizontal force Fx, that will be its mass into acceleration of C, and that acceleration of C is nothing but omega square 3r by 8. I think that should be the answer of this question only.
So it will be m by 2.
M by 2, yes. So m by 2 is 5. R omega is V.
So
So
omega
why
is
are
100.
not we taking any friction?
It is in pure rolling motion. So why I will take any friction? It is non-accelerated pure rolling motion.
Yes, so if it is purely rolling, then there has to be some friction. Because otherwise, how is it rolling without slipping?
We have discussed so many things about role of friction in pure rolling. Do you remember that?
Yes, sir.
If a body is already in pure rolling motion, is friction needed for that?
No, sir. Oh, okay, sir. Okay, sir. I understood.
No friction is needed. Right, so r omega by r, you can say r square omega square by r omega is v, so it is v square, that means 8 square divided by r is 0.8 into 3 by 8, so it is 8 by 0.8 means 10 into 3 into 5, so I think 150 newton, so x will be 5. Yes, that is the
Yes,
answer
sir.
of this question. Okay. All right, so we have done all these questions on rotational motion. This chapter is over. In next class, tomorrow only, we will start fluid mechanics.